I'm here from CCI. I will give you a presentation today of a PIM analyzer. It is a CCI PIM-Pro product family. At the moment you are seeing the analyzer. This is model 850 with its associated accessory kit. When you open up the analyzer, it essentially has a AC power cord on the inside of the lid for proper connector protection and so on. The accessory kit is a multi-pocketed accessory kit, which allows you to have all of the components, the key components, slotted properly, and of course it has room for additional test cables and so on in a separate inserted pocket right in this location here. The accessory kit has all the proper components for the purpose of verification. To verify system performance, we have two key components, essentially a low PIM load. You'll notice that this particular load has two connectors on it, a female and a male, and essentially is a very high insertion loss cable designed very specifically for the objective of accomplishing a very low PIM load. We also have a PIM standard. The PIM standard is essentially intended to generate a known PIM level at the frequency, at given frequencies of interest. In this case here, with the analyzer, the 850, it will generate a minus 100 dBm signal. The PIM standard can be inserted as a male or female, depending on how your setup is done. Now, you can use the PIM standard to verify that your equipment performance is good, and that we can certainly conclude whether or not we're within tolerances of the set measurement. The AC power cord is set right here in the front, and upon connection, the analyzer can be safely turned on, where it will go through a 1-minute diagnostic procedure. The internal diagnostics essentially verifies that CPU and RF connections are all working properly, and upon successful turn-on, it will proceed to the measurement screen, which allows you to set the analyzer for proper measurement settings. Slight description of the analyzer. Here you will see on the front we have a USB port where data can be stored on a USB memory stick. We also have an Ethernet port where a LAN connection can be connected for remote control via a computer such as a laptop computer. The sound is an indication that we're running a diagnostic, and in this case here it demonstrates that we have an opportunity to save data which might have otherwise been lost. So there is an auto-save report feature which will boot up to allow you to save, retrieve data that might have otherwise been lost due to a power failure. The main screen, the boot up screen, it looks like what you're seeing right now. You're seeing the measurement screens, essentially two measurement screens. One of them is a PIM and return loss measurement, as well as PIM versus time, and two additional diagnostics of RX interference to measure external interference signals, as well as a frequency sweep, which is another diagnostic to find worst-case PIM scenarios while performing measurements. It's, again, an additional diagnostic. The screen that needs immediate setting is a configure system screen, which allows you to set the date and time, and once that has been set in memory, you do not need to set it again, providing you remain on the same time zone. Audio settings is purely setting the analyzer to enunciate whether or not you have an impairment condition or you are below a certain limit. The RF power on timer is a safety precaution icon that allows you to limit the amount of time that the RF energy is on. Due to the fact that we're working at very high power levels, we want to err on the safety side of the timer duration. The manage labels is simply a feature which allows you to set labels, and it can be edited and removed or added to as you wish. We've preset some labels here in the software but certainly anyone is free to edit as they best see fit. The About icon is one where we show you the current software level and also the current firmware level of the analyzer. The IP settings is essentially one where one would set the IP settings for remote control via the Ethernet LAN port. Software updates allows a user to get our current and latest software level, and all that is required to do that is from our website. One can download the latest software and install it via the USB port using this procedure. Additional icons on the front boot up screen is a manage report, where essentially one will visualize all previously saved reports. These are internally saved. Obviously, all reports can be moved to a USB stick as needed. The Manage Resource feature allows you to clean up your memory, transfer many reports at one time, and also to clear out old software rev. Gives you as well a feel for how much memory is left in the system. Quick Start Guide is an abbreviated version of our manual where a user can scroll through all features, all basic functionalities of the analyzer, allowing one to refresh usability of the instrument, to essentially just refresh the mind on using the equipment should one not use it for a while. I will now perform a PIM and return loss measurement in a traditional setup. A test cable is connected and torqued properly using a torque wrench to the front connector, and in this case here I will torque it immediately using a torque wrench which is supplied with the accessory kit. And we'll terminate this cable using our low PIM load as we see right here. Again, all connections should be torqued properly with the associated torque wrench in the kit. So now I'll perform a PIM and return loss measurement, and as you can see from the screen, the measurement comes off in a transmitter off condition, and when you first turn on the transmitter, the RF power, it performs a full calibration procedure. This is roughly a 10 to 15 second procedure. It calibrates both tones, both transmitter tones. In this case here, because of this model being model 850, we have two preset frequencies set at 869 megahertz and 894, and the frequencies generate an intermod at 844 megahertz, as you can see right here on the screen. The flashing red screen tells you that the transmitter is on and that you have some RF energy to work with, displaying the PIM measurement that we're seeing on the screen. Switching back and forth between DBM and DBC just at the touch of the screen allows one to take a measurement by pressing record reading. When you first press record reading, it will allow you to enter information which may be relevant, information such as the operator, site number, technician name, as well as sector and feeder information. This information is required as a buildup of a report which would be submitted at a later date to an operator. While we're building this report, we allow a measurement to be identified with a very specific label. At any time during the report, as you build your report, you may need to change information such as sector and feeder and so on. Should you uncover a mistake in your procedure, you can cancel the previous reading just by pressing the cancel reading function. It allows you to maybe correct for a loose connection or a mishap in your measurement setup. At any time during your setup and your record build-up, you can enter a comment relative to the measurements that you are taking. By pressing on the frequency parameters, one is able to change frequency parameters as you see here. Limits. The intermod relevant to the two frequencies that were entered shows up, and the end user is able to acknowledge measurement of this particular intermod. In this case here, we're seeing a third order intermod, which shows up at 844 megahertz. As one takes a measurements, one builds a test report, which you can scroll through to visualize what measurements are taking place and in what sequence the events were taken. You'll see here that the test point is shown on the graphic, the time of the measurement, the DBC value, equivalent dBm value, as well as return loss, and the result, whether or not it's a pass, a fail, or a marginal condition. At any time during the report buildup, one can save the report as a PDF file, as we are seeing right here, just by associating a file name of choice with the keyboard associated here. Another measurement screen is the PIM versus time. We use PIM versus time for dynamic PIM testing, and essentially one can start a plot just by pressing start plot and collect data as needed. The time axis can be set anywhere between 10 seconds, as we have here, to as long as 4 minutes as required. Again, data can be saved and built in the report. RX interference is essentially a spectrum analyzer function which allows a user to basically measure spectral analysis, interference measurements, and also broadband noise levels, which often interfere with PIM measurements. Frequency sweep allows a user to basically, again, get an assessment of worst-case PIM scenario where the two set carriers sweep from one end to the other, giving us a frequency response in the uplink band of our network. Once you start a plot in the frequency sweep mode, the analyzer does a quick cal, performs its sweep from F1 to F2 and then from F2 to F1, presenting the worst case PIM level associated with the response. Pressing on the menu as I did here below gives you a new PIM versus time function at the two new frequencies which created the worst case PIM seen on the previous screen. It is a wonderful diagnostic for those wishing to seek worst case scenarios in their network. Manage reports allows you to visualize all the current reports in internal memory or external memory should I have a USB stick connected to the front of the instrument. I can copy reports from internal memory to a USB stick and delete reports and rename reports and so on. Manage resources allows one to do a master cleaning of memory, back up all reports taken during a session, clear reports to empty memory, or clear old software as required. That pretty well concludes this tutorial of the PIM-Pro analyzer. Thank you.